Hello everyone, welcome to the channel TopGate. In this video, we'll see the conversion of right linear grammar to left linear grammar. So here I have written the procedure of converting this right linear grammar to a left linear grammar. You can see it has 4 steps. Step 1 says that we have to make the finite automata for the given grammar first. And then step 2, we have to reverse this finite automata. In the reversal, what we'll do, we'll change the initial state to the final state and the final state to the initial state, and then we'll reverse all the arrows. Clear? Then in step 3 it says that then we have to write the grammar of this reversed FA. So whatever we'll get in this step 2 for this reversed FA, what I'll do, I'll write the grammar. Clear? And then in step 4, whatever grammar we'll get, we will reverse the RHS of that grammar. So let's see how we do this. So here I have just taken an example. This example you can see it's a right linear grammar. Right linear means on the right hand side, the variable will be there onto the extreme right position. So you can see here on the right hand side of every production, the variable is onto the extreme right position. So here you can see A is onto the extreme right position, B is onto the extreme right position. Similarly, here also in this production rule, you can see that A is onto the extreme right position, B is onto the extreme right position, A is onto the extreme right position, and so on. So this is a right regular grammar. So we have to convert this right regular grammar to left regular grammar or left linear grammar. So how we do this? The step 1 says that first of all we have to make the finite automata. Well, that's very simple. So we've already seen that how to convert the right regular grammar to a finite automata. You can go to that video and just check it out how we have done that. So what we'll do, let's see. So first of all, we have the initial state, that is S. Clear? Now on S it is saying that with input alphabet A, you will move on to a state A. So I'll apply input alphabet A and let's move on to the state A. Clear? Then again it says that on S, if you apply input alphabet A, you will move on to the state B. So what I'll do, I'll just make a state B and then connect this S with B with input alphabet A. So S is complete now. Now let's move on to the A. A says with input alphabet A, you will move on to the A state only. That means it's a self loop. With input alphabet A, you will move on to A state only. Clear? Then further it says from A, if you apply input alphabet A, you will move on to the state B. So I'll just connect this with B with input alphabet A. And then further it says that from A, if you apply input alphabet B, you'll move on to A only. That means it is a self loop. So I'll just add B here with a comma. Clear? So that means from A, this is a self loop for A and B, and with A you can move on to the B state. Clear? Now let's move on to B. B says B tends to epsilon. That means B is a final state. So what I'll do, I'll just simply mark this as a final state. Clear? So now step 1 is complete. Step 1, we have to make the finite automata of this particular grammar. So we have made the FA for this particular grammar. Now step 2 says that we have to reverse this finite automata. How? By changing the initial state to the final state and the final state to the initial state, and then reversing all the arrows. So what will I do? Let's make it a fresh one here. So here I'll just first of all mark all the states. So let's mark all the states and don't mark any arrows. So first of all it says that the final state will become the initial state. So B was final here, so it will become my initial state, and S was initial here, so it will become my final state. Now we'll change the arrows. S to A, it was A, now it will be A to S with A. Correct? Now this self loop will remain unchanged. There is no problem. So I'll just mark as it is A comma B. Clear? Now from A to B, it was with A. Now it will be B to A with input alphabet A. Earlier it was S to B with input alphabet A. Now it will be B to S with input alphabet A. So now this is complete. All the arrows are reversed. Initial state changed to the final state, and the final state changed to the initial state. So now my step 2 is complete. Now step 3 says that now we have to write the grammar of this reversed FA. Now writing a grammar for this particular FA is quite simple. How we do this? Let's see. So we have 3 states. That means I'll write the rules for 3 states. So first initial state here is B. So with B what I am having? So with B, B derives A, A. That means if you apply input alphabet A on B, then you'll move on to the state A. So that means B derives A, A. So B derives A, A. Then again, from B, if you apply input alphabet A, you'll move on to the state S. That means from B, if you apply input alphabet A, you'll move on to the state S. That means B derives A, S. Correct? Now B is complete. So now let's move on to the A. So for A, you can see we have three outgoing edges. That means if you apply input alphabet A on A, you'll move on to A. If you apply input alphabet B, you'll move on to A. If you apply input alphabet A, you'll move on to S. So I'll just write the production rules for A. So for A, what do we have? First of all, if you apply A, you'll move on to A. Second one is if you apply B, you'll move on to A again. Third one is if you apply A, you'll move on to S. So this is complete now, and then we'll move on to the S. S is not having any outgoing edge, and since it's a final state, so what I'll do, I just simply derive epsilon from S. So this is my step 3. Okay, so let's write, this is my step 3, this was my step 2, and this is my step 1. So this is the grammar that we have got after completing step 3. Now step 4 says that now we have to reverse the RHS of this grammar. So this grammar, I have to just reverse the RHS. That means this part has to be reversed. So let's write step 4 also by reversing the RHS of this particular grammar. So first of all, what do we have? We have B tends to small a, capital A. Now after reversing, what we'll do? We'll just write this capital A first, followed by this small a. So what will I have? That is B tends to capital A, small a, reversed. Then again B tends to AS, now it will be reversed. That means capital S, small a. Now let's write for A also. So for A, what do we have? This will be reversed. Capital A, small a, slash capital A, small b, slash capital S, small a. And then this S derives epsilon will remain as it is. So just I'll mention here that B is the start symbol here. Okay. So in this grammar, if you see, this S was the start symbol. After converting this right linear grammar to the left linear grammar, B becomes my start symbol. So this is my required left linear grammar for this right linear grammar. So I hope this is clear to you now. Thank you so much.